going to be 3 variable Karnaugh maps. And we have to use something other than binary numbering to use it, something called gray encoding. So I want to show you what gray encoding is. So it's G-R-E-Y. Just want to check on that. G-R-A-Y. Gray encoding. I'm going to check that because I thought it was an E. I just want to make sure that you guys can look this up later. Gray encoding. That's with an A. Gray encoding. Gray codes. And they're an important thing that, so they didn't have an engineering class when I was in high school. But I did see this in university, I think in my 2nd or 3rd year. So gray codes. So they are something that learn it and it'll be valuable for you if you go into engineering. Gray code. So here's the idea behind gray codes. We're going to be changing 1 bit at a time. 1 bit at a time. This is a more efficient way of sending values because only 1 bit has to be changed at a time. So here's the numbering for gray codes. I'll do 2 digits. So we got 0, 0. Should we do 3? No, 2 is good. So 0, 0. That's going to be 0, right? The next one is 0, 1. And can someone look at this and tell me what should the third one be if we're only allowed to change 1 bit at a time? So 1, 0 would be what we would do with binary numbers, but the problem with that is that we're changing both bits. We can only change 1 at a time. Yeah, we can't do 0, 0 because it's already been used, so we must change this bit, so we'll end up with 1, 1. Then it goes 1, 0. So this is the correct sequence of 2-digit gray code. Let's do 3. It'll be 8 long still. We still use all the same combinations. So 2 digits still has 2 to the power of 2. 3 digits still has 2 to the power of 3. It's just in a different ordering. Yeah, so let's see that. Now online, they're just saying that it was blurry. Is it, it's okay for everybody? And also, if it was blurry for you, for whatever reason, maybe low bandwidth, I'm going to make the videos available later as well. So I'm recording these. Okay, 3-digit gray code. We have to start with 0, 0, 0. Sorry, what were you going to say for the next? 0, 0, 1. 0, 1, 1. Yeah, 0, 1, 0. So it's the same as 2-digit gray code, and then it changes once we have to carry. Now, what happens here? Guys, you know I teach these courses once a year because I've got so many courses I'm doing. I just don't want to make a mistake here. So I'm just looking back on my notes. So for 4 variable K maps, we've got even with 4 variable, you only need to do 2-digit gray codes. You don't need 3-digit gray codes. But so we don't actually use 3-digit gray codes. But let's see what it is. So who says, so what, sorry, what were you saying? It's going to be 1, 1, 0, and that makes sense. Let's see what they have online here. For 3-digit gray codes, they have 0, 0. Yeah, 1, 1, 0, you're right. 1, 1, 0, makes sense, right? So you can only change 1 bit at a time. So you can't do 1, 0, 0 like you'd want to in binary numbering, but 1, 1, 0 makes logical sense. Yeah, now I think we're going to do 1. Actually, they do 1, 1, 1. They do 1, 1, 1. We don't need to know this, okay, because we're not going to be using it. And then they do 1, 0, 1, and then they do 1, 0, 0. So you only need to know this. But I thought I'd show you that it is possible for 3-bit and 4-bit as well. So let's do an example now with 3 variable K map. I'm going to get rid of this because we only need to know the 2 variable anyway. So now you know gray codes. So 3 variable I'm just going to call it K-Maps, okay? Not K-pop, K-Maps. All right. So here's how we'll break it down. And we still have a chart with columns and rows. So we're going to put A there, and then we're going to put BC. BC will make up our two-bit gray code. A will still be one bit. We have 0 and 1. But B and C, we need 4 bits. So now we're going to use our gray code up at the top here. So we have for BC 0, 0, 0, 1, 1, 1, and then 1, 0. The reason why they chose to use gray codes for K-maps is so that the wraparound works. I want you to just observe that any two columns or any two rows that are adjacent, let's look at the columns. So any two columns that are adjacent, because they're using gray codes, they're only different by 1 bit. So only one thing changed. So this is like, let's put what they represent up here. So this is A naught, this is A. This is like B naught, C naught. This is B naught, C, B, C, and then B, C naught. So if you look at any adjacent, meaning neighboring or touching each other columns, they're only different by 1, right? So there's always going to be something in common. And with the wraparound case, there's still something in common because it's gray codes. Okay, so let's take a look at an example. This is how we set up our variable K-map. So let's see an example now. So we're going to say so A naught, B naught, C naught all ANDed together, and then A naught, B naught, C, or A naught, B, C, or A naught, B, C naught. So all we're going to do is transfer each one of these terms, each one of these 4 terms, into our chart there, and then see what we end up with. So A naught, B naught, C naught. There's going to be a 1 right there to represent that. Let's use blue for the next one. I'll run out of colors, but so this is A naught, C. A naught, B naught, C. So there's a 1 there. I think it does help to write this. If you want to write that there, the actual variables with the knots, if it helps, go ahead and do that. And then we have A naught, B, C, A naught, B, C. And then we have, I'll just use this green for this one, A naught, B, C naught, A naught, B, C naught. So we've got the full first row, all 1s. Everything else is going to be a 0, so I'll just put a 0 in everywhere else. So remember our rule here. We want to use the fewest number of groupings possible. We want to use groupings of 2, 4, or 8, or 16, powers of 2, basically. So we can do one grouping of 4, and then we're done. So what we found out here by using this K-map is that we can list all these terms on top of each other and see what cancels out. This is still a very trivial example, but believe me, these K-maps are they save lines and lines of simplification and rules. This can be used with any expression that can be done with ands and ors. But you do have to get into ands and ors first. All right, so the C naught here cancels out with the C. This C naught cancels out with that C. There should be the same number of C's and C naughts, and if there isn't, that means maybe something went wrong. There's 2 B naughts and there's 2 B's, so those cancel, and then we're left with A naught. So therefore, T equals A naught. It is. So that test was testing your knowledge of the Boolean algebraics simplification rules. Yeah, so, well, there's a situation where you have to use some of the rules first. So if I gave you an XOR, or if I gave you like something that wasn't in this form, you'd have to make it in this format with ands and ors only before you continued. So if it was an XOR, or if it was something like this, remember something like that, you'd still have to know De Morgan's rule to simplify that, for example. Most of the rules that you learned are still good, but a lot of the simplification rules where the algebra, you got bogged down with the algebra, that's where this comes in handy. Okay, so that's example 1. I can do example, let me see, I want to do 3 more examples. They're all kind of different. This next one will be, see how it's very valuable to use this. So example 2, here's the expression, and it's a longer one. A naught, B naught, or C naught, and then we have A naught, B naught, C, and then A naught, BC, A naught, BC naught, ABC. Finally, so there's the expression there. Just check that I copied it out right. Okay, so here we'll design it. Because it's 3 variables, every 3 variable K-map, no matter what the letters are. I mean, if it was X, Y, Z, you just use X, Y, Z here. So we have A, and then we have BC. You can make it longer than it is, longer this way, or wider, I mean. And don't forget the gray encoding. All right, so we have our first term right there. Our next term here, got A naught BC, got A naught B naught, or no, A naught BC naught. So it's still the first row, but now we have ABC. ABC is there, and then A, B, C naught is over there. So now you can see that we're going to have to use more than one grouping. So for the first grouping, you want to do powers of 2. So this one here. And you can make your groupings as big as possible. And here's my next grouping, these 4. So even if they're not linear, if they're like this, you can still list them on top of one another. So that's how this example is a bit different. Okay, so we have, I'm going to start off with the horizontal grouping first. So A naught, B naught, C naught. A naught, B naught, C. A naught, BC. A naught, B, C naught. So there's my first grouping. And there's an equal number of C's and C naughts, so those cancel. There's an equal number of B's and B naughts, so that cancels, and we're left with A naught for the first grouping. The next grouping, that's the square, or the box, we have A naught, BC, A naught, B, C naught, A, B, C, and finally A, B, C naught. We have an equal number of C's and C naughts, so that cancels. We have an equal number of A naughts and B's, A naughts and A's, and we're left with B. So therefore, T equals A naught or B. Just remember that the two terms, if you have more than one term, they're ORed together. Now, there is an even more powerful algorithm to simplify expressions that's done online that they use in the colleges and universities in the labs. But K-maps are good enough for us. So 2 more examples, and then we're done. Any questions about this? And it's visual too, so it's not really algebra at all, I don't think. It's a little bit of it, but not much. So next example. So I've chosen examples that have different that are grouped in different ways, so you can see these are grouped. So here's the question. We have P equals A naught B naught C naught, or A naught B naught C, A naught BC, or A naught B C naught, A naught B naught C naught, and finally A B C naught. Let me check that that's right. Thank you. So this should not be a naught over here. That's just A. Okay, that's correct now. So same as before, we'll set it up the same. So A naught B naught C naught is there. A naught B naught C, A naught B C. They're not always going to be in order like this. A naught B C naught, A B naught C naught, and A B C naught. This time we have like a sideways U, an upside down U shape. So remember, we want the fewest number of groupings possible. So we could do a grouping of 4, and then a grouping of 2, and another grouping of 2. But there's a way, because we can use wraparound to use, only 2 groupings. But we're still going to use that horizontal of 4, and it does wrap around, but now we're going to use this one. So here's our last one. So it wraps around this way. So 2 groupings. So let's write out everything and see what cancels out. There's an equal number of C's and C naughts, so that cancels. An equal number of B naughts and B's. You guys can really appreciate this too, because you know how much work goes into this simplifying. So by just putting one big swoop down to cancel that out, feels really good. And then we have our next grouping of 4. This is also a grouping of 4. So this is the wraparound. So there's our first one, our second one, our third, and our fourth term. So the second term is now A B naught C naught, and then A naught B C naught, and A B C naught. So the A's and A naughts cancel, the B naughts and the B's cancel, and we're left with C naught. And that's it. So we're done. T equals A naught or C naught. These examples are specifically chosen. First of all, they're in the correct format already. And then one last one I wanted to do with you, where we have an interesting, a different type of grouping. You've seen the wraparound case. Any questions before we go on? One last example. And the other thing is, you can take this and you can do a truth table to check that it actually is correct. You can do a truth table for the unsimplified expression and the simplified. It would take you a long time, but then you could see that it actually is correct. So here's last example. Is this number 4? Yeah, number 4. So there's only 4 terms here, so they don't all have a lot of terms. And I think if you were given this, you'd have to use several rules, Boolean algebra rules, to simplify. This one definitely saves time with the K-map. So we have a naught over top of the A, then a naught over top of the B, then over the C, and then no naughts. So those are the 4 terms. So remember to make this longer because we have 4 things. Oh, BC. stronger than my own good. Okay, 0, 1 for A, and then we have 0, 0, 0, 1, 1, 1, and 1, 0. So the first term, A naught BC, A naught BC, so there's a 1 there. A B naught C, so A B naught C. A B C naught, A B C naught, and ABC. Okay, so it looks like a triangle here. And remember, it has to be groupings of 2, 4, or 8 powers of 2. So I don't think there's any tricks to this one. I think that we just have to group it. There's no way that we can do a grouping of 4, is there? Always start with something higher and then work your way down. So just groups of 2, right? So we're going to have to do that. And then we can't do a grouping of 3. So we have to do a grouping of 2 like this, and then a grouping of 2 like this. So we're going to have 3 groupings. No way around that. So we have, I'm going to do the vertical one first. So A naught BC and ABC. And then the next one is, I'm going to do the one on the left. So this just cancels those 2. So we're left with BC. Okay, so we have A B naught C and then ABC. So the B's cancel and we're left with AC. And finally, we have on the right side, we have ABC and then AB C naught. C's cancel, C and the C naught cancels, we're left with AB. So therefore, the best we can do for T is, and I'm going to write it, I'm going to try to write it in the most alphabetical order I can. So AB, ORed with AC, ORed with BC. So it doesn't always work out as cleanly as we'd like it to. All right, so that's the examples of 3 variable K-maps. Anybody have any questions with that? I'm going to make this video available online as well. Okay. All right, I'll stop recording, and there's going to be a worksheet that is going to be on content section momentarily.